Okay, so this is an online lesson for day one of our notes for functions. Main purpose today for today's lesson is simply going over the old materials just to make sure that we are all on the same page, knowing some particular skills that we have to get ready for the school year. Okay, so now let's look at these questions one by one, and I will make sure that I emphasize those main points as we go over the lesson. First one, you can see that we have a little function right here. Okay, this function, it's called f of x, and it's equal to x squared plus 2x minus 1. So, and then we have three parts. We have A, B, C. Part A seems to be pretty easy. So you may pause the video and actually try to do these three questions first. And then when you're ready, you can resume this video and then we can go over this together. Okay, assuming that you have done your trial, your attempt. So let's go over these three parts together. All right, so f of -2. Now, I always tell students that it's very important that you know what you're reading. Okay, so your notation, it's going to be very, very important. Your ability to interpret the notation, it's going to be crucial to your success in math in general, and of course, your pre-calc, and of course, your future success in calculus. So I'm not kidding when I say notation is important. Okay, it is very, very crucial. Okay, very, very crucial for your future success. So when we say f of -2, I would say most people should know how to do this, but if you don't, well, to make sure you do the following. Now, we are going to substitute -2 into x. Now, what I want to emphasize here is that when you do your substitution, make sure that you use a pair of parentheses for every single substitution. So let's take a look. So x squared would become -2 square. Make sure you put parentheses around the -2. And then plus 2 times -2 minus 1. Okay, so now the reason why you should have a habit, you really should have a habit of using parentheses, is because it makes the picture so much clearer for yourself and of course for anyone who is reading your work. And you will have less confusion while you are doing this. Okay, that's number one. The second thing to emphasize here is that, well, maybe your previous teachers, your previous math teachers may tell you to check your answer when you finish doing it. I mean, that's good for the past, but we actually would say it's better to check your work while you are working on it. And the way you do it is just to broaden your scope. Okay, broaden your vision. So when you are writing this, go ahead and scan the line above just to make sure that all the signs, all the numbers, all the substitution were written correctly. Because you really don't want to waste your time doing something that's incorrect. So I would not encourage that you check your math at the very end, okay? Because that's already too late. So you should check your work while you are doing it. So you should develop a habit of looking your writing and looking what is shown, the line above. Okay, so that's my second point of emphasis for this problem. Now, the third and probably the most important point of emphasis here is that a lot of students, they don't have a habit of writing equal sign after they finish a line. And it is a really bad habit if you don't write an equal sign. Now, the reason why it's a bad habit, well, for now, is that, well, you kind of assume people know that is an equal sign right there. Then why don't you write it? That's number one. Number two, after years and years of teaching and tutoring this course, Algebra 2, Pre-Cal, Calculus, I can confidently say that students who tend to skip the writing of an equal sign, they tend to have a very miserable time in calculus, and of course in pre-calc too, because they don't appreciate the importance of notation. So please, from now on, if you did not have this habit of writing equal sign, you would get on to this habit, okay? You will write equal sign as you show your steps, okay? Every single step when you are changing some sort of expression, please, 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 please write an equal sign, okay? On the left end, by the way, okay? So, well, parentheses -2 squared is 4, okay? Not -4, it's 4 because -2 times -2. Okay, you have two negative numbers multiplying together. That's 4, positive 4. And then 2 times -2, it's -4. So that's why it's -4. And then we have -1. We are very delighted to see 4 minus 4, which is 0, and then -1. So the final answer is just -1. Wonderful, easy, 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 easy stuff. Now let's go ahead and look at the part B. Okay. So now if you can do part A with no problem, then you should have no problem doing part B and part C. However, some students may not be able to do this because you know, inside the parentheses, you know, f of x minus 2. It's not like a number. It's not a simple number. So some students may have, you know, some phobia about this kind of expression. It's uglier. Okay. Now, the point is this: if you know how to do f of -2, you should be able to do part B and part C. The key is that try not to think this as a different thing. It's the same thing. I'm going to highlight this. All right. I'm going to highlight this with a little blue color. So -2, you substitute -2, right? So it's x minus 2. So go ahead and substitute x minus 2 into the place of x. Okay, I understand that we're substituting with an expression with x, so that could cause a little bit of confusion, but don't get scared. All right, it's just your psychological overthinking. All right, so if you know how to do f of -2, this is the same thing. All right, this is the same thing. Now, let's move on to the next step. Well, x minus 2 squared. Now, this is the reason why I wrote something on top. Some students may write this, okay? And I'm going to write this with a different color to show that this is an incorrect one. Some students may write this. This is not correct, okay? This is not correct. Okay. And the reason why students got confused with this is because they didn't realize that, well, the square means you multiply by itself, right? And you have a parenthesis. So you have actually x minus 2 times x minus 2. So it's something like this on top right here. And when you have this, well, that's why you need to do FOIL. So, so let's take a moment to make sure that we are doing this properly. And we say, okay, so let me go ahead and show our work right here. Now, you may go ahead and distribute the 2 right here. So we get 2x minus 4 and minus 1, okay? And then go ahead to the FOIL. So you have x squared minus 2x minus 2x minus, no, sorry, plus 4. Plus 2x minus 4 minus 1. Okay, so, and we can see some like terms here. We can see like terms right here. Okay, so we should combine them. Oh, actually, we should combine this one too. So we have x squared minus 2x. All right, now it's really wonderful because hey, minus 2x plus 2x, they're gone. And also plus 4 minus 4, they're gone. So therefore, we just have x squared minus 2x minus 1. Okay, easy, easy, easy. Now, same thing for part C. Okay, it's something strange, all right? It's ugly, but don't be scared. It's just something you substitute for x. So x plus h, use parentheses for your substitution. X squared plus 2xh plus 2xh plus h squared. And then you can distribute this one. 2x plus 2h minus 1. Now, I went ahead to do the FOIL right away because I can see that we need to do FOIL. I would say it's really important that you can do this as quickly as possible. If not, it is going to be a major trouble for the future, because we do expect students to know how to do FOIL and also factoring, the easy one, fairly quickly. Okay, so that's the first example. We just want to show, we want to see if you know how to do substitution. We want to see if you can carry out some basic skills like, you know, doing square, doing FOIL, combining like terms. That's it. Okay, that's it. All right, now let's move on to the next example. Let's move on to the next example. So we need to find a domain. Now, if you remember from Algebra 1 and Algebra 2, we talked about domain and range. So if you forgot what they are, so let me just write it on the side. So domain would be the possible x values, and the range is the possible y values. Okay, so very easy, very easy. Okay, now one thing I do want to teach here, to remind you here, is that we should ask questions as we are looking for domain and range. So when we look for domain, we're like, what are the possible x values? And at the same time, I would suggest you to think about, what kind of what kind of x values, what can't x be? I mean, what can't x be? All right, is there any x value that x cannot be? Okay, we should investigate those. Okay, so now let's take a look at part A. Okay, so now I want to detour a little bit right here. I want to give you a little challenge. Okay, so I'm going to draw a pair of axes. So I want you to do a quick sketch of this function. Okay, so we can pause this video, draw a pair of axes, and then do a quick sketch of this function. All right, go ahead, do that. Okay, so assuming that you have the graph drawn. Now, this is a linear function. Okay, and it cuts the x-axis at -3, and it cuts the y-axis at 3. And as a pre-calc student, I would expect that you can recognize that this is a linear equation. And in particular, this is a slope-intercept form. Now, if you somehow forgot the 3 forms of linear equation, it's time to brush up. Okay, so there are 3 forms. We have the slope-intercept form, we have the point-slope form, and we have the standard form. If you don't know them, I guess it's a good time to find out online or from your book, and just to review, write them down, and then just to remind yourself. Okay, so now if you look at this graph, okay, now the reason why I ask you to draw a graph, because actually if you have a graph, it makes a lot of things easier. Because you can just look at the graph and say, hey, what are the x values for this function? And we say, well, are there any x values that x cannot be? We say, well, it goes all the way left and right, so x could be, anything. So we say, all right, x is, well, all real numbers. Now this would be good for set notation. Okay. In this course, we will use set notation, and we will also use the interval notation. And you probably should have learned before, but if you forgot, that's fine. Let's go ahead and review. Now, since x, it's all real numbers, so that means it goes all the way from -infinity to infinity. Okay, so we use parentheses. Okay, so to say that, all right, it goes from -infinity to infinity. If it includes the number, we use a bracket, but since we don't know where the infinity ends, so we just use you just use the parentheses to include them. Okay, so this one's easy, fairly easy. Okay, if you have the graph, that would be brilliant. Now let's look at part B. Now part B, it's a little bit more, complicated. Okay, now I would like to ask you to take a look at this function and see what kind of things you see and anything that bothers you. Okay, let's take a look. So if you ask me, look at this expression of this function. What bothers me is that I can see a square root, and I can also see that hey, it's a fraction. So if you want to do well in pre-calc, we would say that well, from algebra 2, you learn about square root functions and rational functions. In case you forgot, well, there are some restrictions for these functions, meaning that, hey, there's some values that x cannot be. So let's take a look what x cannot be. Well, for the numerator, okay, let's take a look at the square root function. And we say that, oh yeah, x cannot be negative numbers, because if you put a negative number, it would be imaginary. Now, if you can try to put it into your calculator on your phone, you can put a negative number in the place of x, and then you take the square root of that, and the calculator would probably say error, because your calculator doesn't know how to show any imaginary number. If you use a TI Inspire, then it may show you something like it's imaginary, something like that. So yeah, so if you have a square root, just make sure that whatever thing that's underneath the square root must be at least 0 or above. So we can think of one condition already, which is x must be greater than or equal to 0. But that's not the only place we see x, so we have to consider the other x in the function, which is in the denominator. And when we talk about denominator, we'll say, yeah, if you have a fraction, the denominator, now listen to this very carefully, it's the denominator that cannot be 0. Okay, the whole denominator cannot be 0. Okay, so let me highlight the denominator. Let me highlight this with a better color. So the whole denominator cannot be 0. So then we think about, what x value will make the denominator 0? Well, it's pretty easy. If you have a 5, 5 minus 5 is 0. So we say, you know what? X cannot be 5, because we want this function to perform normally. Okay, we don't want undefined, we don't want imaginary numbers, so we have these two conditions. So we say, yeah, x has to be greater than 0, and x has to be well, x cannot be 5. So if you merge these things together, then we say, well, you can think about this as a number line. Actually, you can say this is 0, this is 5, and then we say, all right, we shall have an open circle at 5 because we cannot include 5. And we have a closed circle at 0. So it goes all the way to 5. And then we will skip 5. And then we'll keep going all the way to the right, to infinity. So if we want to present this in set notation, we can say x is greater than or equal to 0, but less than 5. And then we can say x is greater than 5. Okay, we can say that. Now, if we use the interval notation, well, meaning would be the same. It's just the expression being different. We use a bracket because this time we include the 0. Okay, x could be 0. Now, should have said this earlier. If you don't believe it, that we can include 0, we can put in 0 in the calculator and take a square root out of it. And you'll find out that square root of 0 is 0. Okay, if you don't trust me, you can look at the calculator, you can consult the calculator and prove it to yourself. So 0 to 5, not including 5, union 5 to infinity, close parentheses. Okay, so that's the interval notation. So for this particular one, like what we do in PreCal, or actually back in Algebra 2, is that we showed you different kind of functions, and we want you to know the behavior, okay, of different kind of functions. Like you learned about linear back in Algebra 1. You learned about quadratic functions, cubic functions, square root functions, square root function. What else? Rational function, like the ratio, one way you see the x in the denominator. You have exponential function, logarithmic function, all these functions. If you are truly proficient, you will be able to tell the behaviors or the features of these graphs or these functions, and also draw the graphs for these functions. But if not, well, you may go ahead and review them, or just pick them up as we go over, because the first few weeks, or actually the first couple months of PreCal, it's basically a review of Algebra 2. So we'll get a chance to review them. So no worry. Okay. So in the next video, we'll talk about the next example. So here, we'll talk about this example in the next video.